everybody, welcome to my YouTube channel. So today we're going to be dealing with question 3 of tutorial sheet 3. So dealing with this particular question, we're going to be dealing with asymptotes and how to find them. So when dealing with the asymptotes, there are certain rules you need to be aware of. You have to make sure that you know and understand these rules, and if you can, please master them. So I will leave the rules, I'll write them down in the description. So do not forget to subscribe and hit the notification bell so that you are aware whenever I post a video. So let us begin. So the first question that we are going to be dealing with is question 1, which says x plus 2 over x plus 3. So according to our rules, this will have a vertical asymptote and it will have a horizontal asymptote, but it will not have a slant asymptote. So the first thing we're going to look for is the vertical asymptote. So when finding the vertical asymptote, initially you factorize first, but because this is unfactorizable, we're just going to equate the denominator to 0. So after we do that, we minus on both sides of the equation, which will, at the end of it all, it will give us x is equal to -3. And that -3 is our vertical asymptote. And that is basically it. So when it comes to finding the horizontal asymptote, due to the fact that they are all of the same degree and the highest degree is 1, we're going to divide the coefficients of the x's with the highest degrees, and that's just 1 over 1 because those guys don't have coefficients, so it's automatically just 1. So it's 1 over 1, which means our horizontal asymptote is 1. And yeah, that's it. So when finding the slant asymptote, because of the rules, we know that this equation has no slant or oblique asymptote. So our question B, which is x minus 1 over x squared plus 1. Question, because of what the rules state, this question will have no oblique asymptote, and the horizontal asymptote will be non-existent as well, and also the vertical asymptote will automatically just be 0, just due to the rules. You don't really need to do any math here, but yeah, those are our asymptotes. So we just have one, which is the horizontal, which is. So for this question, first we're going to find the oblique asymptote. So you're going to find the oblique asymptote through long division of the respective equations through a process of long division, and it will look like this when you divide it all out. And the important answers, the actual answer, is what you get at the top, the x plus 1, and that is what you're going to use as your oblique asymptote. So I cannot explain this entire process in detail to the fact that I do not have the most time in this video, but I will leave a link in the descriptions on a more detailed version of how to do the long division. But at the end of it all, the oblique asymptote is x plus 1. Whatever remainders you get, honestly, for finding those asymptotes in this situation, they really, you can disregard them completely. They really don't hold any value. So now when finding the vertical asymptote, remember we're just going to equate the denominator by 0, change the subject of the formula by adding a 1 on both sides, and that the 1 on the left side will cancel out, leaving a 1 on the right, which will make x equal to 1. And that is simply our vertical asymptote. So for this question, based on the rules, it will not have a vertical asymptote, and it will also not have a horizontal asymptote. It is extremely important to always remember the rules, but we can find the horizontal asymptote. Because of they are of the same degree, we're just going to divide the coefficients of the x's with the highest degrees, which will mean you're going to have a horizontal asymptote of 5x squared over 3x squared. Excuse me. So the x squared will cancel out, which will leave you with just the coefficients on their own, and that will be 5 over 3 as your horizontal asymptote. And that is the answer. So for this question, the first thing we're going to find is our horizontal asymptote. And because we can't simplify this any further, we're simply going to equate that denominator by 0. So when you equate it this way, you're going to make x the subject of the formula. So what you're going to do is subtract the 4, first of all, on both sides. So you have a -4 on the left and a -4 on the right. So the -4 on our left, those two, the positive and the negative, they'll cancel out, leaving you with just a 3x is equal to -4. So what you're next going to do is divide 3 on both sides to isolate the x. So -3x over 3 equal to -4 over 3. So that will only leave an x equals to -4 over 3, and that is our asymptote. So now when finding the oblique, we're going to find the oblique through an extremely tedious, I find it tedious personally, process of long division. Please, I'm not able to explain it in this video, but I will leave a link definitely in the description for those who are interested. So the process will look like this. It will have a lot of fractions, but don't worry, don't get intimidated by the fractions. And whatever remainder you get, remember the remainders are insignificant when finding the asymptotes. What matters is what you get at the end of the day. So your oblique asymptote will be x over 3 minus 4 over 9 as your answer. And yeah, that's it. It's not as difficult as it may seem. But yeah, that's how you do it. So for this question, the first thing we identify is that the highest degree in the denominator is 3 and the highest degree in the numerator is 2. So the difference between them is 1, and the greater value is the denominator, which means that automatically our horizontal asymptote is 0. So based on the rules, we do not have an oblique and we do not have a vertical. There is no mathematics required. We just have a horizontal, which is 0 only. So that is all for this question. Thank you so much for watching. Please do not forget to like and subscribe if you enjoyed the video, and leave a comment down below. Guys, please remember that there are rules to these. Please go through them, and good luck in your studies. Thank you so much for watching.